So all those sugars that were bonded together in that big starch molecule, and I'll show you a different picture. This is from your reading. When they're together, they have a very different taste than when they're apart. And I'm not even sure that your taste buds can, have the right size receptors for those bigger starch molecules. So you had to chew it up in your mouth, literally, and with the help of what? To break it into sugar. So what else was helping besides the fact that you were just chewing?
Saliva.
What's in your saliva?
Amylase.
Amylase, good. Called salivary amylase. And so you have this enzyme in your saliva that helps you break it down further. Now, what does chewing do for you? I mean, other than the fact that it gives you a little bit of time, and it kind of prevents you from choking usually, because you're chewing your food to make it smaller, what else could the chewing be doing to that food? I want you to think about it a minute. Why do we chew our food? And we chew crackers. We don't just chew big pieces of steak. Reggie?
Because when we chew the food, it breaks it down into smaller parts so the saliva can get eat away at it easier.
Good. And what is Reggie kind of describing? We're increasing what about the food? What are we increasing?
Surface area.
Surface area. So the more molecules that can come in contact with one another, the faster we're going to digest our food. And so the saliva, the amylase in the saliva gets at those molecules a little bit quicker. Okay, so that's called mechanical digestion and a little bit of chemical digestion. So if I go back to this picture here, what exactly do enzymes do? Now I will tell you this is a very important topic in biology, and I do remember in AP biology, it's usually one of the longer, you do like a couple essay questions, they almost always ask about enzymes because they power so many reactions in biology. So if this green kind of puzzle piece here is representing the enzyme, that would, in our case, be amylase in our mouth. And then the substrate, the purple kind of puzzle piece, is representing the starch, the thing that the enzyme is acting on. Now, what the enzyme does is notice that these two pieces, how were they related? How do they look like they're related? They fit together, almost like a puzzle piece. In fact, they used to call it a lock and key hypothesis. Well, it's not always a perfect fit because this is just a visual representation, but there's a temporary chemical bond that forms between those two molecules, and it actually stresses out the starch molecules enough that they begin to fall apart. And the end result over here is two maltose molecules, which is a type of milk sugar. So not the big starch molecule you started with, but you get two maltose, which is very different. So we went from a polysaccharide, lots of sugars bonded together, to a disaccharide, because there's just two rings of sugar here. And that's what you started to taste the longer you kept that cracker in your mouth. Okay, so does that make sense? There's an interesting connection with evolution that I wanted to share with you. And there's been a lot of research lately in human evolution. And how do we determine where humans came from? Well, we talked about how humans, originated in Africa. There's very good evidence that we all migrated out of Africa at one point or another and went to live in different parts of the world, whether it be Asia or Europe, and the continents, of course, are very different then. But it's interesting that if you have something called lactose intolerance, and maybe you would admit that, or maybe you don't know because every time you eat ice cream you feel really sick, chances are that you maybe lack an enzyme to break down lactose. So that enzyme would be lactase. So it's interesting that if your family, your distant relatives, came from herding families, more of a pastoral existence where you had goats and sheep and cows and you milk them, you probably can break down milk well into adulthood. But if you kind of came from a group of people that didn't do that, that maybe had different occupations, maybe they were hunter or gatherer type people, they actually kind of lost this enzyme over time through evolution. So it's interesting because a lot of human evolution is based on the proteins that we can make. Remember we talked about how DNA codes for proteins. So it kind of is interesting to think about it in that way. So if you know yourself, maybe there's people in your family that can't break down lactose, that's probably why. So they just don't make this enzyme, the green piece, that could stress those bonds and break it down. So it actually makes you physically sick. Henry?
So how would that end up making you sick? Like, what is the food?
That's a great question. I think because maybe the molecule stays a little bit larger in your digestive system, or perhaps that just the act of trying to break it down maybe causes like intestinal distress because those molecules are too big once they hit the intestine, whereas most of our food is already broken down once it gets into the intestine. Because the intestine is kind of all about absorption. It's like a really slow road through the digestive system. But the stomach and our mouth is all about chemically breaking things down before it hits our stomach. So there's another interesting, experiment that went on in terms of digestion. So how many people